In this video, we'll solve few problems based on continuity. Alright, let's look at the first one. See, prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and at x is equal to 5. So, first part what we'll do is, we'll start off by taking the function itself. See, f of x is equal to 5x minus 3, correct? So what we'll do, first we'll put x value as 0 because my first part is what? Taking x as 0, isn't it? So first what do? Take f of 0. This is going to be 5 into 0 minus 3, which is nothing but minus 3, correct? Now, if my function has to be continuous, what is the definition? The definition is limit as x tends to c, f of x is equal to f of c, correct? This is how you define it. So in this case, limit as x tending to 0 f of x, isn't it? Which is nothing but limit as x tending to 0 5x minus 3. Now when you apply the value, you are going to get minus 3 itself, isn't it? So what did we prove? Don't you think we proved this particular condition? Because when you take the limit and when you apply the value, in both the cases, the answer is minus 3 itself. So what can we say? That f of x is continuous at x is equal to 0. So we proved for x is equal to 0. Let's do the same thing for minus 3 as well as for 5 now. For minus 3, what are we going to do? First, let's apply f of minus 3. So 5 times minus 3, minus 3. So minus 15 minus 3, which is negative 18. So f of c value is minus 18, which is nothing but f of minus 3, correct? Now, the next thing what we do, the limit part. So limit as x tends to minus 3, f of x, limit as x tending to minus 3, 5x minus 3. So this is nothing but 5 times minus 3, minus 3, which is minus 18. So since we proved that limit as extending to c f of x is f of c, you can say at the end saying that f of x is continuous at x is equal to minus 3. This is also done. Now the next part, which is x is equal to 5. For the next part now, what you have, f of 5 is equal to 5 into 5 minus 3, 25 minus 3, which is 22. So f of c is nothing but 22. Now again the next part, limit as x tending to 5, 5. Next you have f of x. Limit as x tending to 5, you are going to have 5x minus 3, which is nothing but 5 into 5 minus 3. So that's 25 minus 3, which is 22. So we proved here also, we proved the same thing. So at the end, what you can write, that f of x is continuous at x is equal to 5. Clear? So this is how you prove the first question. Prove that the function is continuous. And you proved for all the three. Let's do the second one now. See the second one, what you have, examine the following functions for continuity. Now when they say examine, there is no particular value or range or nothing is given. So we just take an arbitrary value of k and we prove that okay, it is continuous or not. Understood? So here what we'll do, first question, f of x is 1 by x minus 5, correct? We don't know what value of x do we have to take, isn't it? So what we'll do is we'll take some arbitrary value, say x is equal to k, some value k, all right? So now what do we do? So we have f of k is equal to 1 by k minus 5. Now when we say k, x is equal to k, one simple condition, or you can say a very important one also, that is k is not equal to 5. We cannot have a denominator to be 0, isn't it? That's why k is never equal to 5. So now what do we do? F of k is 1 by k minus 5. Again the condition. So the condition what we have is limit as x tending to c, f of x is equal to f of c. Now if you apply this limit as x tending to k, f of x, which is 1 by x minus 5. Now remember, here we have specified that k is not equal to 5. That means here, in place of x in the limiting case, we can apply the value of 5. Sorry, we can apply the value of k, not the. So what we are going to get, this will be equal to 1 by k minus 5, isn't it? So what did we just prove here? We just proved that limit as x tending to k, f of x is nothing but f of k. Since these two are equal, what can we say? That f of x is continuous in that region, because k value can be anything, isn't it? So f of x is continuous at every point. At every point. Except which point? X is equal to 5. Understood? So this is what we mean, or this is how we prove, not prove, I would say, discuss the continuity of this particular function. Understood? Now we'll go for 2b. B, what do we do? Look at the function. F of x is equal to mod of x minus 5. Now, one thing you have to notice, guys, there is a thumb rule for solving all these problems. Okay, so the first is apply some value k. All right, once you have the value of k, in certain cases you have a restriction, like in the previous one, that you cannot be equal to 5, something like this. Apply x is equal to k, and once you have the value of k, calculate f of k. All right, then once you have f of k, find the limit as x tending to k. Now then you have to prove that the limit value and f of k value both are one and the same. If you prove one and the same, that means it is continuous everywhere. If not, it is not continuous. That's the whole point of examining the continuity. And the same thumb rule we are using even for this question also, the second question. So now what do we have? F of x is equal to mod of x minus 5. So first we'll do f of k, mod of k minus 5, isn't it? Again, the limiting condition. So you have limit as x tending to k, f of k, sorry, f of x, isn't it? F of x is equal to f of k. This is what we need. Now apply limit as x tending to k, mod of x minus 5. So this will be nothing but mod of k minus 5, because that value of x, we can take it as the value of k. So mod of k minus 5. So once you have this one, isn't that the same as f of k? Like look at this one. So this one and this one are one and the same. So what did we just prove? We proved that since limit as x tending to k, f of x is equal to f of k. By definition of continuity, f of x is continuous everywhere, or you can say f of x is continuous at every point. At every point, f of x is continuous. Understood? So this is how we solve 2b. Now we'll go for 2c. See, f of x is equal to x square minus 25 divided by x plus 5 under the condition that x is never equal to negative 5. Again, it's very similar to the first one, isn't it? Now, let's look at this one. Here, x square minus 25. Can we not write it as x plus 5 into x minus 5? Isn't it? Divided by x plus 5. X plus 5 cancels out. So what is f of x then? F of x is just x minus 5. Guys, we did not change the function, but we simplified the function, isn't it? Since we simplified the function, now what do we do? F of k minus 5, isn't it? Then what we do? We take the limit. So for the limit, we'll do it here. Limit as x tending to k, f of x. So this becomes limit as x tending to k. We just have x minus 5. And this value is going to be k minus 5. Correct? So we can say, since the condition, or you can say by definition, the function is continuous. So we can say that f of x is continuous at every point, including x is equal to negative 5. The reason is, when x is equal to negative 5, that x square minus 25 by x plus 5, the x plus 5 cancels out. The function is going to be just x minus 5. So you can apply the value. Understood? So this is how you examine the function continuity. Alright, let's do the next problem. See the next one. Discuss the continuity of the function f. Here 1, 2, 3, there are 3 questions. Look at the first one. See, you have f of x which has 3 functions here. 2x when x is less than 0. So whenever we take the left hand limit, we take this function. Then 0 if x is between 0 to 1. Then 4x if x is greater than 1. So discuss the continuity of the function, isn't it? Now what we have to take is, guys, we have to take 2 parts here. One is with respect to 0, one with respect to 1. Now let me show you how to go about it. Okay. Now first we'll do LHL, but LHL with respect to point 0. So you can write LHL with respect to 0. Now limit as extending to 0 minus. 0 minus would be nothing but the left hand, this particular function, this function. Correct? So this is going to give me 2x. Correct? So since it is 2x, and if you apply the value, you are going to get this as 2 times of 0, which is nothing but 0. So well and good. So we got LHL as 0. Now, RHL. Again, with respect to 0 itself. Now for the right hand limit, what function do we use? We use the second function. See this function. Greater than or equal to 0, isn't it? So now what do you do? RHL with respect to 0. So you'll get limit as x tending to 0 plus. The value of the function is 0 itself. Since we don't have any f of x or the variable x, you can just write it as 0. Done. 0. Now the limit itself, that is limit as x tending to 0 f of x. What is f of x at x is equal to 0? 0 itself, because look at this point. X is less than or equal to 0. Sorry, x is greater than or equal to 0, isn't it? So equal to is also there. So limit as x tending to 0, you're going to get the value as 0 itself. So what can we say? That function f of x is continuous at x is equal to 0. Remember, at x is equal to 0, and this is not done because we also have that value 1, correct? At x is equal to 0, it is continuous. Okay, now we'll go for that 1 value. 1 value, again, if you take the function f of x, 2x, x is less than 0, 0 when x is between 0 to 1, 4x when x is greater than 1, isn't it? Now again, we'll do LHL. LHL with respect to 1, not with respect to 0 anymore, because 0 part is done. LHL with respect to 1, if you do, see, when you have LHL with respect to 1, we have to take this condition, isn't it? This particular condition. So what do we have? Limit as x tending to 1 minus. So your f of x value is nothing but 0, correct? Then if you take the limit exactly at that point, or first we'll do RHL. If it's not equal, then no point in going at that value, isn't it? So when you do RHL with respect to 1, you have limit as x tending to 1 plus f of x, isn't it? So you're going to say limit as x tending to 1 plus 4x, which is 4 into 1, 4. See, my LHL is 0, my RHL is 4. They're not even equal. So what do we have here? LHL is not equal to RHL. So what can we say? So f of x is discontinuous at x is equal to 1. So when we say discuss the continuity, we can say that it is continuous at x is equal to 0 and discontinuous at x is equal to 1. This is how we discuss the continuity. Because there are 2 points, one is 0, one is 1, you have to calculate at both the points. Understood? Let's do the second one, which is very similar to this one. For the second one now, see what do we have for the second one? F of x minus 2 when x is less than or equal to minus 1, and 2x when x is between minus 1 and 1, 2 when x is greater than 1, correct? So let's do this one. So f of x, first we'll take LHL with respect to -1, correct? So first point, what do we have? LHL with respect to -1, limit as x tending to, so here it's gonna be -1 minus, -1 minus, the negative sign on the top, the superscript represents the left hand limit, correct? F of x, and this value is what? -2, correct? Go for RHL. If this is true, go for the value. RHL with respect to -1. So what do we have? Limit as x tending to -1 plus f of x, correct? This is going to give me, see, what is my function? Limit as x tending to -1 plus 2x. This is going to be 2 times -1 minus 2. Okay, so now we have LHL is equal to RHL. Now we go for the value of the function. That is limit as x tending to -1, and when it is -1, my function value f of x is what? -2 itself. Look at this condition. X is equal to -1, it is -2. So now what do we have? All the three values are equal. See here, -2, -2, -2. All three are equal. So what can we say? F of x is continuous at x is equal to -1. So now we'll go for x is equal to 1. All right, equal to 1. Now what do we have? We are going to take again f of x minus 2, then 2x, and then finally 2 when x is greater than 1. Right? Now LHL with respect to 1. Limit as x tending to 1 minus f of x. So what is my left hand limit for 1? See, this is the condition, correct? So left hand limit is going to be 2x, correct? So function becomes 2x. So limit as x tending to 1 minus 2x. Put x as 1, so you are going to get this as 2 into 1, which is 2. So LHL is 2. Now we'll go for the RHL value. So RHL with respect to 1, isn't it? So what you are going to have? A limit as x tending to 1 plus f of x, isn't it? So here when it is RHL, see, this is your function, isn't it? So this is going to give me just 2. So LHL, RHL both are equal. So now we'll look into the function value, that is limit as x tending to 1 f of x. When it is equal to 1, see this, there is an equal to sign here. So what do? This is equal to limit as x tending to 1 2x. 2 into 1, which is 2. So what do we get? LHL, RHL, function. All three are one in the same. Since all three are one in the same, we can tell that the function is continuous at x is equal to 1. Or in other words, what can we tell? Since the function is continuous at x is equal to minus 1 as well as 1, at the end we can tell that f of x is continuous everywhere. Function is continuous everywhere because at every point you consider the function is being continuous, isn't it? LHL, RHL, everything is equal. So function is continuous at every point or everywhere. Understood? Let's do the next one. You have f of x is equal to sin x plus cos x. No range, nothing is given. But what we do know is that, see, you know that sin x is continuous everywhere. Sin x is continuous everywhere. So what we can tell is, since sin x is continuous everywhere, now the next one is what? Cos x. Cos x is also continuous everywhere, isn't it? Say sin x is continuous everywhere, cos x is continuous everywhere. Now according to the algebra of continuous functions, now if both f and g are continuous everywhere, then the sum of two continuous functions is also continuous, isn't it? We have proved that in the last video. So what do we have here? That let f of x is equal to sin x, alright, and let's say g of x is equal to cos x. Now what do we have here? We have f of x plus g of x. So sum of two continuous functions. So we can say that since both are continuous, the sum of the functions is also continuous. Hence, f of x is, which is sin x plus cos x, this is continuous everywhere. Alright, this is continuous everywhere. Now we'll solve the next problem in the next video. Pause.